All right, we are on page 5 of our notes. We're looking at notes 10.3 about completing the square. This is our first day of multiple days of looking at completing the square. So the first thing that we need to do, question number 1, it says write the following standard form quadratic expressions as perfect squares. So basically, all it wants us to do is to factor it. So if you look right here, x squared plus 12x plus 36, all I'm going to do is figure out how to factor it. There's no GCF, and it's not a difference of perfect squares. However, it is a perfect square trinomial. So let's go ahead and try to factor it. So here, I'm going to look for two numbers that multiply together to give me x squared. So I would say x and x. And here, I would look for two numbers that multiply together to give me 36. And this is nice because it's 1x squared, so I don't really have to worry about carets for this. So the numbers that multiply together to give you 36 and add up to give you 12, again, I can go straight to adding up to give me 12 because my carets, when I multiply by 1, it's going to be the same number as what I have here, and then this outside caret is going to be the same number that I have here with an x added on, right? So two numbers that multiply together to give you 36 and add up to give you 12 are both 6. So 6 and 6 right here. So you end up getting x plus 6 quantity squared. Okay? And then in the next one, it's almost the same thing, except in order for it to multiply out to give us positive 36 but add up to give us negative 12, they both have to be negatives. So this would be x minus 6 quantity squared. Okay? All right, so now let's take a look at the next example. X squared plus 20x plus 100. So I would look for two numbers that add up to, or multiply together to give me 100, but add up to give me 20, and those numbers are 10 and 10. Okay, so again, it's x plus 10 squared. Now, if you take a look at this, you should probably notice something right here. All I have to do to figure out what this answer is take the square root of 36, or, which is the c value, so I would take the square root of c, or I could take the b value, the 12, and divide it by 2, or again, take b, divide it by 2. Either way, in both of these examples, you get 6. So that's how I get this 6 right here. So right here, I would take the square root of 36, which again could be plus or minus 6, we said, right? So then when you take negative 12 and divide it by 2, you end up getting negative 6. So that leaves us only with negative 6, and that's how we get this value right here. So again, in summary, the most important thing that you need to do is square root the c or divide the b in half, okay? So let's take a look at the next example right here. So I could either square root the c, so I could take 9 over 4 and square root it, and I would end up getting 3 over 2, right? Positive 3 or negative 3 over 2. Or I could take the b value, which is negative 3, and divide that by 2. So that means that the only answer I care about is negative 3 halves. So then, if that works, if I square root this number and I get negative 3 halves, and if I divide this number in half, the b value, divide it in half, and I still get negative 3 halves, then it's a perfect square trinomial. It's a perfect square trinomial, so it works, which means that when I factor it, I'll end up getting x minus 3 over 2 quantity squared. Okay, let's just double check to make sure that it works. So I'm going to take x minus 32, or excuse me, x minus 3 over 2, and then multiply it by x minus 3 over 2. Negative 3 over 2 times negative 3 over 2 does give me this 9 over 4. And then when I do my carets, I get negative 3 over 2, x. And then out here I get negative 3 over 2x. And when you add negative 3 over 2 to negative 3 over 2, you end up getting negative 6 over 2, or negative 3, so that works. It's a perfect square trinomial, okay? So let's take a look at the next example right here. If I were to take the square root of 2500, I would end up getting plus or minus 50, okay? So then, if I were to take the b value, cut it in half, I would get positive 50. So regardless of how I do this, I would get positive 50 either way. So that means that it is a perfect square trinomial, so it would be x plus 50 squared. All right, now let's take a look at the last one. If I were to take the square root of 3, I can't evenly, it's an irrational number, so that doesn't really work for me, unless if I divide 8 by 2, I end up getting the square root of 3, but 8 divided by 2 is 4, so this is not a perfect square trinomial, which means that it's not factorable. And the reason why I can conclude it's definitely not factorable is not only is it not a perfect square trinomial, there's no difference of perfect squares, there's no GCF, and it's not a trinomial that can be factored any other way. All right? Before we do questions 1 and 2 on the bottom of our page, I want to go over something with you guys really quickly. So if I gave you a problem like this, x squared plus 6x plus 9, and I asked you to factor it, you should figure out that it would be x plus 3 times x plus 3. Or just simply x plus 3 squared, because 3 times 3 is 9 and 3 plus 3 is 6. Also because 6 divided by 2 is 3, and the square root of 9 is plus or minus 3, so I would use the positive version because this is a positive number right here. Now, if I didn't tell you what this value is right here, you could figure this out. So if I instead said, figure out what the C value is right here, all you would have to do is, and remember we got 9, so we'll talk about how we get 9. All you have to do is take the B value, divide it by 2, right? And then in order to get the C value, you have to take this number and you got to square it. So it would be 3 squared, right? And we get the 3 by doing 3 times 3 here because 3 plus 3 is 6. And then 3 times 3, or 3 times itself squared, is 9. Okay, so this means that the C value would be 9 right here. All right, so another example would look something like this. Here's another example that might make sense to you. So if you had x squared plus 10x, and I asked you to figure out what the C value is, what you have to do is you'd have to take the B value, cut it in half, and then square it. All right, so the B value is 10. You cut it in half and square it, so you get 5 squared, which is 25. All right, so that means that the C value should be a 25. So take a look at this right here. If I were to do x squared plus 10x plus 25, and I want to factor it, I could factor it easily because all I'd have to do is x plus 5 squared. And again, here's your value right here. When you take 5 and you double it, you get your B value, and when you take 5 and you square it, you get your C value. So this is the missing value that you would get. All right, let's do another example really quickly. So if you had something that looked like this, x squared minus 3x, and I asked you to figure out what the C value is. So remember, we said all you have to do is take your B value, divide it in half, and then square it. So you end up getting negative 3 over 2, and then you got to square it. So this means that you end up getting negative 3 squared means negative 3 times negative 3, which is 9, and then 2 squared is 2 times 2, which is 4, so you would end up getting 4. So that means that your C value is equal to 9 over 4, which brings us back to the exact same problem that we did right here, where it was x squared minus 3x, you had to add 9/4 to it, and it ends up being x minus 3 over 2 squared. Okay? All right. Let's read the directions for the bottom 2 questions. Find an expression equivalent to the expression below that includes a perfect square binomial. So if it's equivalent, it means that they're going to say the same thing, even though they might look a little bit different. So what I'm going to do is I'm going to copy down the ax squared plus bx terms, and then I have to leave an empty spot because I want to complete the square. That's what this lesson is about. What number do I add on that will complete the square? So what is this value right here? But then I copy the rest of the problem down because I'm not allowed to change it, all right? So how do I do this? All I have to do is figure out what is missing right here, and we've already discussed how to do this. All you have to do is take your B value, divide it by 2, and then square it. That's the missing piece right here. So when I take 8, which is my B value, divide it by 2, and square it, I end up getting 4 squared, which is 16. So that's the missing piece that I have right here. Once I write plus 16 in this box, my square has been completed because 4 times 4 gives you 16 and 4 plus 4 gives you 8, which means that I will be able to factor this out as x plus 4 quantity squared. However, if I add 16 right here, then I have changed the problem. I've added 16. It's 16 bigger than it was before. So if I do that and I want an equivalent expression, I got to make up for it. So if I add 16, I can get rid of it by subtracting 16, right? Won't these two cancel each other out, this 16 and this negative 16? Absolutely. So you need to add the opposite to cancel. All right, so you end up getting x plus 4 quantity squared, and then figure out what this is. When you combine these together, you get minus 13, which means that your original expression, this x squared plus 8x plus 3, is equivalent to x plus 4 quantity squared minus 13. And if you were to actually multiply this all out right here, using the box or using the distributive property, and then you were to subtract 13 from that answer, you would get this answer right here. They are equivalent to each other, so you haven't really changed anything at all, okay? So let's take a look at question number 2 together. In question number 2, you've got x squared plus 9x plus 11. So I'm going to do the same thing. I'm going to copy down the problem, the x squared plus 9x, and I'm going to leave a box right here to fill in so that I can complete the square. I got to figure out what the missing number is that will complete my square. And then I'm going to write plus 11 on the side over here. So how do I complete the square? The exact same way that we've talked about multiple times before. You take the b value, divide it in half, and then you square it, okay? So you would take 9, divide it in half, and you would square that. So you would get 81, because 9 squared is 81, over 4, because 2 squared is 4. So I would get 81 over 4, all right? But if I'm going to do that, if I'm going to add 81 over 4 right here, I have to balance it out by subtracting 81 over 4 over here. So now the question is, how is this a perfect square trinomial? What number can I square to get 81 over 4, but also double to get 9? And that number is right here. It's your number before you square it. It's the b over 2 value. So all I have to do is say this is x plus 9 over 2 quantity squared. And let's just double check to make sure that that's really true. So open up a calculator document, and then you're going to type in 9 over 2 in parentheses, because the whole entire number is being squared, and see if you get 81 over 4. Absolutely you do. So this is the c value you want. Now I'm going to take 9 over 2 in parentheses, close them to show that your fraction is over, and I'm going to double it. I'm going to multiply it by 2, and I get 9, which again is the value that I want right here. So it's x plus 9 over 2 squared, and then I got to figure out what this number is right here. So I'm going to figure out what 11 minus 81 over 4 is. I have two options. I can use my brain, which is the option that I would prefer you guys to do, okay, and get a common denominator. So let's talk about this right here. 11 minus 81 over 4, this is 11 over 1, so my common denominator would be 4. So I'd multiply this by 4 and multiply this by 4, so I would end up getting 44 over 4 minus 81 over 4. Okay, which would end up giving me negative 37 over 4. All right, so this right here would mean that I would have negative 37 over 4. And this is my final answer. This is my expression that is equivalent to this expression right here, where I have completed the square. Okay, and again, if I were to multiply out x plus 9 over 2 times x plus 9 over 2, and then subtract 37 over 4 from that, I would indeed get 11 as my answer, okay? So let's just show how we can do it on our calculator to begin with. We can just take 11, subtract 81 over 4 from 11, and you end up getting negative 37 over 4. Let me show you how you get the same answer. Let's actually multiply it all out together really quickly, and then we will be done with our video for today. So let's see. This means x plus 9 over 2 times x plus 9 over 2, right, minus 37 over 4. All right, so when I distribute through, let's erase this on the side right here. When I distribute through, x times x is x squared. X times 9 over 2 is 9 over 2x. 9 over 2 times x is 9 over 2x. And 9 over 2 times 9 over 2 is 81 over 4 minus 37 over 4. Okay, so then these two combine together, and if you add 9 halves plus 9 halves, you end up getting 18 halves, which is just plain and simply 9. All right, and then if I were to add 81 over 4 with negative 37 over 4, when you do 81 minus 37, you'll end up getting 44 over 4, which is the 11 that you want. So again, this is proof right here that this expression, this x plus 9 over 2 squared minus 37 over 4 is equivalent to x squared plus 9x plus 11. All right, make sure you come with questions. See you next class.